We will now look at question 7 on the reaction mechanism. And so the first part is to write down the overall reactions that has occurred. So there are one way I try to do this and make it less confusing for myself is I will try to remove all the catalysts and the intermediates from these reaction mechanisms. All right. So remember, a catalyst or intermediates, they will not appear in the overall reactions, because for a catalyst, it will be consumed and actually regenerated again at the end of the reaction. So the catalyst in this case is aluminium chloride. So it reacts in step 1, and then it is regenerated and produced again in step 3. So I know this is not going to appear in my overall reaction. For the intermediates are chemical species that are produced during a reaction itself, and it will get consumed again before the end of the reaction. So one intermediate we have in step 1 is AlCl4 minus. We see that it is produced and eventually consumed in step 3. Other than AlCl4 minus, we have Cl plus, which is also an intermediate. So it is produced in step 1, consumed in step 2. The last intermediate we have is C6H6Cl plus. Okay, this is produced in step 2 and consumed in step 3. So basically, all these species that we have over here, they are what we call the intermediate. Now, so what will be the chemicals that are left in the overall reactions? We have the reactant Cl2, C6H6. These two species chemical will produce the C6H5Cl and HCl, and this is your overall equations. So with this, we have already covered B and C. We will now look at part D. Now, part D is actually very recall questions. All right, so hopefully you managed to memorize and reproduce the 3 characteristics of the catalyst. You can give any of the 3. All right, so the first one is that catalysts provide an alternative pathway with a lower activation energy, and therefore increasing the rate constant. Okay, the last part here is frequently left out in many of the students' answer. Part 2, a catalyst is often specific in character, so it only works for a particular type of reaction or a particular reactions. Now, a catalyst is chemically involved in the reaction, but it is chemically unchanged and regenerated at the end of the reaction. So this we can actually see it quite clearly from the reaction mechanism just now. The last characteristic, it does not affect the yield of a chemical reaction. So let me just explain this a little. When we talk about yield, let's say we have 60% of a reactant being converted to the product. So when we don't use a catalyst. So with the use of a catalyst, we will still have 60% get converted to the products. So in terms of yield, it is still going to be 60% yield. But what is difference is that I'm going to get the 60% of my yield of my product within a shorter period of time, because the rate of reaction is increased, but the yield remain unchanged. In part E, we will now draw a fully labeled energy profile diagram for the reactions. Note that the overall reaction is exothermic. Now, before we start drawing, you need to have some sense of what is energy level profile diagram. So basically, this is a visual representation telling you how the reaction actually progresses via the reaction mechanism. Now, it also shows the energy level of all the chemical species that is involved. Okay, it also shows the activation energies as well as the enthalpy change. So all these are the informations that you will need to put down on your diagram, okay, to make this a fully labeled energy profile. So to draw this diagram, first of all, we need to go back to our reaction mechanism again and refer to it. Okay. So the shape of your curve for energy profile diagram depends on what we are seeing in the mechanism as well as the enthalpy change for the overall reaction. So please check your curve. Your curve should have 3 peak with 3 activation energy. Okay, so every steps will have an activation energy to climb, and therefore, if you have 3 steps, I'm going to have 3 peak and altogether 3 activation energy. Now the slowest step is low because it has the highest EA. Okay, so highest activation energy must be there for the second step. Now, because this reaction is exothermic, okay, this is an exothermic reaction, this means that my product is going to be very stable. When it is formed, it is going to release a lot of energy. Therefore, my final energy level in this particular example, it must have the lowest energy level. And for the intermediate energy level, take note that because after my step 1 and step 2, I do have intermediates present. So intermediates are unstable, and therefore we will expect the intermediate energy level to have a higher energy compared to the start and the final. So with all this in mind, this will be the shape of the graph that you should have. All right. So we are plotting a profile diagram showing y-axis being the energy, and the x-axis is the reaction coordinates. So our graph, you can see there are 3 harms. The highest harm is for the second step because this is the slowest step. The final energy level is the lowest, okay, compared to the other 3, okay, because our enthalpy change is exothermic. The intermediate levels, these are intermediate levels. Here are the levels with unstable intermediates. Therefore, we expect them to have higher energy level. Now, this is not the end. We need to put in the species, chemical species present at each energy level. So what do we need to include? We need to include at the start. Okay, at the start, what we have is it should be all the reactants and the catalyst. Take note, I need to put in the catalyst because the catalyst is involved in the reaction. So therefore, the reactants will be the chlorine, benzene ring C6H6, and the catalyst AlCl3. The last stage will be the stage with all the products and the regenerated catalyst. So our product for the reaction is actually C6H5Cl, HCl, and the regenerated catalyst AlCl3. For the 2 intermediate level, you will need to show what are the species present at each level. Okay, so they basically contain the intermediate species, unreacted reactants, and or the products from the previous step. So to write the chemical species, you need to refer to the mechanism again. Okay, so if you look at the step 1 of your mechanism, the step 1 involves my catalyst reacting with my chlorine. So this will be form AlCl4 plus, this is minus, and Cl plus. Okay, so the benzene C6H6 is unreacted, so it should be there. In the next step, step 2, we have the intermediate, which is Cl plus reacting with C6H6. So we're going to form C6H6Cl plus as our intermediate. We still have an unreacted intermediate, which is AlCl4 minus. So the last step will involve the change, the reaction between these two intermediates, giving us the final product as well as the regeneration of the catalyst.